Hello, everyone. My name is Wei. I will present a paper titled as Embracing Collisions to Increase the Fidelity of Sensing Systems with the COTS Tags. This is a joint work with my colleague Jiaqi and my advisor Kannan Srinivasan from the Ohio State University. So we know that RFID sensing has been widely exploited in the era of Internet of Things. Here are some background. The RFID system consists of reader and multiple tags. It utilizes the slotted Aloha protocol to interrogate the tag. Collisions happen during RN16 transmission. The collided tags need to select another time slot to transmit. So let's first see how collision affects sensing systems. So given one time slot, only one tag can be interrogated due to the slotted Aloha protocol, or even distribution in channel gains can lead to some tags being read much more frequently than the others. So we define the time resolution of one tag as the number of channel states that can be measured within 1 second. So this figure shows the time resolution for different tags. As we can see, tag 3 has the highest time resolution, but tag 1 just has the lowest time resolution. So the different time resolution of different tag will degrade the RFID sensing systems accuracy due to collisions. So previous solution to avoid the collision can be divided into two types. The first one is MAC layer design, which cannot work with COTS tag. The second one is a physical layer design. It can only support 3 to 5 tags, and it cannot support a COTS tag. From these two figures, we can see that for 2 tags, when they are colliding in IQ domain, we can clearly separate them. But for 5 tags, we cannot. So our solution, so the main purpose of the sensing system is to extract the channel. And our core idea is to retrieve the text channel from the collided data, meaning the RN16, and match the channel to the corresponding tag ID without decoding. So our work is better than the others because for n tags we need only to identify n channels rather than 2 to the power of n different states. So this is the design overview of our system. COFFEE represents a collision-free RFID-based sensing scheme. There are 4 modules. We first detect the collision, and then we extract the channel, and then we match the extracted channel to the corresponding tag ID. So at last, we have error detection. If the error larger than a threshold, then we discard the extracted channel. Otherwise, it is good to use. So our system is compatible with the C1G2 and can assist all the RFID-based sensing system that are utilizing the channel information to do the sensing. So we have 3 key observations to enable the design of our system COFFEE. First observation is very responsible delay. The second observation is the stable bit duration of the tag. And the last one is continuous channel variation. First of all, we need to extract the channels. Our core idea is extract channel based on the order of arriving time and cancel the transmitted data after channel estimation. There are 3 steps to extract channel. First, we separate one channel. We identify the tag ID of this channel, and then we cancel the signal to obtain the other channel. The evaluation, in the evaluation, we use USRP as the reader, and we use different commodity RFID tags. First of all, we validated the channel estimation for device-free sensing. As we can see, the error remains relatively low when multiple tags collide. So for the device sensing, with the device sensing, as we can see, when tags move faster, the error increases. That means our system can support less concurrent sensing. So in the system level test, we can see that the medium gain with 4, 8, and 16 tags could achieve around 3 times on average. We also do the human activity recognition with or without our proposed system, which can be in which we can see our system can improve the accuracy of human activity recognition. In a conclusion, we propose the coffee to leverage physical layer information without any modification on the RFID tags to improve the RFID sensing system. And our system is compatible with C1, G2, and can assist all the RFID-based sensing systems. This is the reference of our presentation. And with all that being said, I'm happy to take any questions.